minus 90. And we can write the multiplication of cosinus omega t plus delta, multiply cosinus omega t plus delta minus 90. We can write this form, and this will be converted to final form. The PLT will be VIL sinus 2 omega t plus delta. Please write, if I want to plot this function, will be this form. It has very important point. Let's see, in this year, the average magnitude of this PLT will be 0. This means the reactor cannot absorb any power, any average power. Okay? The average of this form will be 0. No problem? Okay. I continue by purely capacitive load. We consider the idle voltage source connected to pure capacitor. Okay, in pure capacitor, ICT here equal IC max cosinus omega t plus delta plus 90 ampere. Please see, we know the current in the capacitor will be lead from voltage, and the angle for lead will be in pure capacity load will be 90. Please see, in inductive is lagging by 90. This is the leading by 90 degrees. Okay. Okay. If you write here purely capacitive load, ICT will be here, PCT, the instantaneous power to the capacitor will be multiplication of VT ICT, and you can write this form, and this form, and finally this form. Please see, in this year also the average load will be 0, but between this condition and this condition, we can see very, very important difference. Please see, difference between PLT and PCT is here is plus, here is minus. This means the difference angle between PLT and PCT equal 180 degrees. If this here is the positive section, this here is the negative section, and others. Here is positive, here is negative. Okay, this means the PLT and PCT have difference angle equal 160. Okay, no problem. Okay, I want to go to general RLC load. It is the concluded from 3 cases: resistive, capacitive, and inductive. And I want to connect it in this here idle voltage source to general RLC. In this network, we have in same time resistive, inductive, and capacitive. This means the general RLC load. I want to write PT, the instantaneous power, absorbed by the general RLC. Okay, no problem. Okay, I want to have break. I think 10 minutes or 50 minutes enough. We come back to lecture in 2:45. Okay, please go for eating something or drinking tea or coffee, and please come back in 2:45 minutes and continue our lecture by general RLC load. Okay, thank you for your consideration. Minus omega t plus 10, and I here is a 50 cosinus omega t minus 10. Okay, no problem. Okay, the problem wants us for computing the real power in this network. You see, we can write easily real power equal effective value of the voltage, 100 divided to radical 2, okay? Multiple in 50 divided to radical 2. This is the RMS of voltage. This is RMS of the current. Multiple on cosinus. Let's see here. Delta is 10. Minus beta here is minus 10. The general form is omega t plus beta. Beta is minus 10. Minus 10. Will be real power equal 100 divided to radical 2, 50 divided to radical 2, cosinus 10 minus 10 will be 100 radical 2, 50 radical 2, cosinus 20. If you compute this formula, you can reach to active power of this general RLC load. Okay, no problem. Okay, let's see. We define other term is called power factor. Let's see here. We define cosinus delta minus beta here. Delta minus beta is called their power factor. For each network, we can write power factor. Power factor is defined the cosinus delta minus beta, or write cosinus phi. In many references, delta minus beta is defined phi. It's called cosinus phi or power factor. Power factor is the cosinus, angle of voltage minus angle of current. No problem? Okay. And the reactive power is defined by Q equal VIX. IX is I sinus delta minus beta. The dimension of the Q is var, and the dimension of the real power is watt. You see here is watt, and here is the var. The dimension of reactive power is var, and the dimension of the reactive power is watt. Q will be VIX, VI sinus delta minus beta var. Okay, no problem. Okay, I want to continue lecture by example. Let's see here. The voltage VT equal 141.4 cosinus omega t is applied to a load consisting of a 10 ohm resistor in parallel with an inductive reactance XL equal omega L equal 3.77 ohm. Calculate the instantaneous power absorbed by the resistor and by the inductor. Also, calculate the real and reactive power absorbed by the load and also power factor. Let's see. In this example, first want for calculate the instantaneous power absorbed by a resistor and also by inductor. Okay. Voltage RMS equal 141.4 radical 2. Okay. The phasor voltage will be 100 with angle 0. No problem here? Okay. The angle of the phasor of voltage 0 and the RMS of voltage is 100. And the resistive current is the VIR equal 100 divided to 10. R is 10. Okay, 10 ohm. Will be 10 with angle 0. Please see, in this here, V delta is 0, and in IR, delta is 0 also. Okay. Inductive current. ILV divided to JXL will be 100 divided to J3.770 will be 26.43 with minus 90 ampere. Minus 90 ampere represent the lagging of the current in the inductive in comparison with the voltage. Okay. Total load current will be I equal IR plus IL. IR is 10 with 0 angle or 10, and IL is 26.53 minus 90 will be here. And the IL is the current in the network, summation of the current in the inductive and also in resistive. In this here, I will be 28.35 minus 69.34 ampere. In this here, instantaneous power absorbed by the resistor will be PRT equal 100 multiple on 10. It is the RMS of the voltage, is the RMS of the current in the resistive, and will be 1 plus cosine 2 omega t watt. This is the part of the instantaneous power absorbed by the load, the resistive load. And the next slide. And for PLT, you can write RMS of voltage multiple on current in the sinus 2 omega t. And in this year, we have 2653 sinus omega t, okay? No problem? Okay, by writing the active power is 100 watts and the reactive power is 2653 watt, and in this condition you can write power factor equal cosinus delta minus beta. You can write cosinus equal 69.34 degree and will be 0.3528 lagging. The current of the network has 69.35 degree lagging from the voltage. Okay, this is a complete example for definition of phasor, for instantaneous power, reactive power, and power factor in the systems. Okay. Okay. I want to terminate the lecture here, and I continue in next sessions in next week, inshallah, from physical significance of real and reactive power, and also the definition of complex power in power systems. If you have any comment or any question, please let me to know. Again, I want from one of them, let's see, for example, Lara or Arisade or other students, one of you, please open a WhatsApp group, okay, with title Power System Analysis /221/2, okay, and please add all our students in the session in WhatsApp. Thank you, Arisade. And add also my number in this group. I will send you some exercises, some references, some messages for you. Please refer to this group for having connection with me about this course, okay? Okay, if you have any comment, please let me to know. If you have not, I want to say to you, inshallah, for next week, I continue the complex power concepts. Thank you for your attendance, and also have a nice day in weekend, and see you, inshallah, in next week. فی امان الله and خدا نگهدار.